What if everything we know about the universe, its beginning, its structure, its very existence, is actually happening inside a black hole? I know, that sounds like science fiction, but hold on, there's some real science behind this, and the implications? They're staggering. In fact, they could rewrite everything we thought we knew about where we come from and where we're headed. Let's back up for a second. A black hole is a region in space where gravity is so strong, not even light can escape. Anything that crosses the event horizon, the boundary of no return, is gone forever, at least from our perspective. It doesn't just fall into a pit. Space and time themselves bend inwards. All paths lead further in. It's not just a hole in space. It's a rupture in the very fabric of reality. Now, here's something curious. Our entire universe also has a horizon, a distance beyond which we can't see anything, not because it's hidden behind something, but because light from that far away hasn't had time to reach us yet. The universe isn't old enough. This cosmic horizon has a size. And when physicists ran the math, they found something strange. If you take the amount of matter in the universe and imagine compressing it into a black hole, the event horizon would be about the same size as our visible universe. Wait, what? That's right, the numbers match almost perfectly. It could be coincidence, or it could mean something far more profound. Maybe we're not outside a black hole looking in, but inside one looking out. See, general relativity, Einstein's great theory of gravity, predicts that black holes don't just crush matter into a single point. They also create new regions of space and time. Mathematically, a black hole can connect to a whole new universe on the other side. In some models, it's even possible that every black hole gives birth to a new expanding universe, separate from the one it came from. So imagine this. A massive star collapses into a black hole in some parent universe. But instead of ending there, that collapse triggers the birth of a new universe, a universe like ours. That would make our Big Bang the bounce from a previous collapse. It's not a singular beginning. It's a continuation of something larger. This idea doesn't come out of nowhere. There are clues all around us, subtle hints that something strange is going on. Take rotation, for example. Recent studies suggest our universe might have a tiny, but measurable spin. This came from analyzing the spin of hundreds of spiral galaxies. If the universe had no preferred direction, we'd expect about half of those galaxies to spin one way and half the other. But researchers found that nearly 2/3 of them spin opposite to the direction of the Milky Way.
That might not sound like much, but statistically, it's weird. Because if galaxies form from randomly moving clouds of gas, their spin should be random too. The fact that so many are spinning in the same direction could mean our universe has a net angular momentum. And where does angular momentum get preserved? Inside black holes. When matter spirals into a black hole, it keeps spinning. That spin becomes part of the black hole's identity. In fact, the only things preserved in a black hole are its mass, charge, and angular momentum. So if our entire universe has a spin, it might be because it inherited it from whatever formed it. Let's break that down a bit further. Imagine a giant cloud of gas collapsing under its own gravity. If that cloud has even the tiniest bit of rotation, it spins faster and faster as it shrinks. This is the same principle figure skaters use, pulling in their arms to spin faster. It's called conservation of angular momentum. Now apply that to the entire universe. If we're all spinning slightly in the same direction, maybe it's because we were born from a spinning black hole, one whose spin shaped the very fabric of our space-time. That rotation could ripple through everything: galaxies, stars, even the structure of cosmic background radiation. And here's where it gets even more interesting. Black hole cosmology isn't a fringe idea. Several theoretical physicists have explored it over the years. It's an elegant way to explain some major puzzles in physics, like the singularity problem, the arrow of time, or why our universe has just the right conditions to support galaxies, stars, planets, and life. Let's talk about singularities for a moment. In our current model, the Big Bang starts with a singularity, a point of infinite density and zero volume where the laws of physics break down. But that's not very satisfying. Infinite quantities don't make sense in real-world physics. Now consider black hole cosmology. Instead of a singularity, we could have had a bounce. Matter collapses to a point, but instead of staying there, it rebounds. The result? A new, expanding universe, free of the singularity issue. There's even a physical mechanism that could explain this: the quantum properties of matter. Quantum physics tells us that particles can't occupy the exact same state in space. This resistance to compression could create pressure, enough pressure to counteract gravity at the extreme densities inside a black hole, resulting in a bounce rather than a singularity. In fact, this model might help bridge general relativity and quantum mechanics, two theories that famously don't get along. Because if a black hole can seed a new universe, then maybe our universe is part of an infinite cycle. Collapses lead to births. Death leads to rebirth.
This kind of thinking also opens up the possibility of a multiverse. If every black hole leads to a new universe, then reality might be a branching tree of countless cosmic offshoots. We might be just one of many universes, each with its own physical laws, its own history, and its own fate. And here's a deeper twist. If our universe is inside a black hole, then time itself may behave differently. Some theories propose that the time we experience could be a byproduct of the space-time curvature from within the black hole. Our sense of a beginning, an arrow of time flowing forward, that might be a localized effect. So what would it mean if this were true? If we really do live inside a black hole, it would mean our universe has a parent, maybe many. And maybe one day, far in the future, after our stars burn out and galaxies drift apart, our universe might collapse and give birth to another. We wouldn't be the beginning, or the end, just a link in the chain. It would also mean that some of the deepest mysteries of our universe, like dark energy or the expansion rate of space, might be consequences of how black holes behave from the inside. And that's not just poetic, that's testable. If we can detect a preferred direction of spin in the universe, if we can measure tiny deviations in the cosmic microwave background, if we can find patterns that suggest structure or symmetry across the sky, all of that might point us to our true cosmic origin. We're already building the tools to explore this. Missions like Euclid and the James Webb Space Telescope are peering deeper into space and time than ever before. By mapping galaxies, by measuring cosmic background radiation, by tracking gravitational waves, we're getting closer. And consider this. If future missions confirm even a hint of curvature in the structure of our universe, something just slightly different from the perfectly flat geometry we expect, then that too could point toward a cosmic origin more exotic than a simple Big Bang. It could point toward a black hole birth. Of course, this is still speculation. We need more data. The rotation study only included a few hundred galaxies. There are billions out there. We'll need better instruments, deeper surveys, and time. But even if it turns out to be wrong, the idea pushes us to ask better questions, to imagine bigger possibilities, and to remain open to the fact that the universe might be far more strange and far more wonderful than we ever imagined. Thanks for watching. If you enjoyed this cosmic brain bender, don't forget to like, subscribe, and share it with someone who loves asking impossible questions. Because maybe, just maybe, the answer isn't out there, it's in here.